You're following me now. Your eyeballs are this way. We're going to be together. If you stay right with me, it'll take us about 25 minutes. Okay? Step number 1. Let's come over here. We are going to recap what we learned right before vacation. Okay? Taking a look here. Says in circle W, PWQ is 60 degrees, so sweep it. The radius length is 9 centimeters. I'm recording, so let's not have extraneous. Got it, 9 centimeters. Okay, and we're going to be finding arc length and sector area. I'm going to do this with you as a recap. We did this right before vacation. Measure of a central angle to its arc the same. So if that's 60, that's 60. Now let's go ahead and find our circumference. Go all the way around. C.
D pi. I C D pi.
Again, C. D pi. I C. Okay, ready? Let's write it down. Stay right with me. I'm going to go kind of fast. We trace it, and our diameter, I'm going to start landing on people. Pay attention. Andrea, our diameter is what, ma'am?
18.
Lovely, dear. So this is going to be 18 pi. We check for units. And it is cm, centimeters. So we are good so far. Next, we're going to find the area, which is apple. Pi is?
Very, very good.
Really, really good.
Really good.
Yes? Okay, so here our radius again is 9. So our area is going to be 81 pi centimeters squared. Okay? Arc length. Fraction of circumference. Arc length is what? You missed your cue, folks. Okay. Arc length is fraction of circumference. Arc length is?
Fraction of a circumference.
Great. So our fraction in this case is 60 over 360 times our circumference that we already have. 18 pi. All right?
So it'd be 18 pi divided by 6, so it'd be 3 pi.
You're just a little ahead of the game, and that's perfectly fine. Zeros, and then 6 goes into 36.
3. 6.
6. And then we take the 6 into the 18.
3.
So our arc length,
3 pi.
just write PQ and write the word length. That's 3 pi. cm. That's what we did right before vacation. Okay. Sector area is a fraction of area. Okay. This is, of course, 60 over 360. And we already have 81 pi. Kill the zeros. 6. All right. So this is both divisible. 81 over 6 is divisible by 3. Go ahead and do that.
27 over 3. 2.
And if I wanted exact terms, you leave it as a fraction. And when we say exact terms, that's what we mean. That is your sector area. Just write sector. It's implied that it's area.
That's how you spell sector.
S-E-C-T, that's an O-R. Alrighty, guys. Now, that's a recap. Today, we are doing something called composite shapes and probability. Composite shapes and probability. So, you guys would be dealing with what we just call normal shapes. Let's write our equations for those real quick here in the margin. This area would be base times height over 2.
Base times height over 2, that's area 2. No.
And of course, this area is you average the bases
Over 2.
times the height, which is always creates a right angle. So those would be considered normal shapes. That was one lesson. And then we did a lesson where we did regular shapes. So just hatch mark these. And for this one, it was walk it around. Perimeter times apothem over 2. That was another lesson. Perimeter times apothem over 2. So you have normal shapes, you have regular shapes. Then you have these kind of shapes, is what we're focusing. They're called irregular, also known as composite shapes. And composite shapes are made up of additional shapes. For example, just shade these.
It looks like ice cream.
You
look like ice cream.
And you can see that to get that shape, we have to add together. That's called a composite shape.
I did an Alex topic on this.
Excellent. Then you might be ahead of the game here. All right, we're going to be doing 5 problems together. Okay, a composite shape is composed and I'm going to show you 2 different ways. You have to be able to see both. There's one, just put right here, put an addition sign here. Then on the other page, put a subtraction sign. You'll understand the difference in just a moment. Okay, right here, for the addition sign.
6 times 2.
Hang on. Ready to? No, other way. There we go. Alrighty, guys. So this shape right here we're going to add. We could either go vertically or we can go horizontally. It doesn't matter. You could either slice it like that, right? Or you can slice it like this. I'm going to go horizontally. Okay? It's new. Yes.
Could you just also add in the...
We're getting there. We're getting there. You're on the other side. Okay, so step 1. Let's go ahead and we're going to find the area of the red.
12.
And we're going to find the area. Please don't shout out answers. Let's just do the work here. Okay, this one is going to be 6 times 2, of course. Right? Now this one, we're missing a length. We have 3 here. Okay, ready? Let me show you how to get that. Can everyone trace the 5?
No.
Trace the 5. Now can you squiggle the 2? Okay, and we see we get 3. Now going this way, we have 6. And the 3, so what is this edge right here? 3. So that's going to be 9. So now we add 1 rectangle plus our other rectangle. And we get 21, and it's going to be feet squared. All right. That's called positive composite. Positive composite. There's a second way I want you to be able to look at this. It's called a negative composite. Let's go there. Another way you can look at this is you can see, I like you to physically trace this larger rectangle. Everyone do this right now. You see it? Okay, let's pull out that larger rectangle. And you see this one is 6 times 5,
30.
which is 30 feet squared. And this time, we're going to negative space. We're going to subtract that.
3 and 3.
You have a very good question. You're right. So you go like this. This whole thing is 6. That's 3. This is 3. Going this way, this whole thing's 5. This is 2. So what's from here to here? Also 3. So that means this is 9 feet squared. So to get the green,
That's totally cheesy.
you simply subtract. Okay, that's called negative space. You have to be able to do both. Okay, turn the page. We're going to do 3 more problems together. And then we'll be done.
Hey, stop it.
All right, this one is a positive, and then flip to the right. This one is going to be a negative. So I'm going to give you one more example of each.
Did you just...
Positive,
That's what I hate.
negative.
I literally...
Okay, this first one's called a positive composite. This one is a negative composite. Positive means you add stuff. Negative means you subtract stuff, okay?
I like the adding one.
It's a little bit easier. So for this one, we're going to add, I'm going to make a little, what's called a pictorial equation or a picture equation. So we're going to add, and I want you to learn to make picture equations. A half
Yeah.
plus this equals our total area. Do you see that?
Yep.
Yeah.
Okay, now let's write your equations down. My equation here is area equals pi r squared, and it's half, so it's over 2. This is base times height over 2. Alrighty. Now, do you see the hatch marks? If this is 36, what's this side?
36.
What's this? Okay, great. Got it? Now, I'd like you to trace from the center to the edge. What is that? Okay, so we just found our radius. So our radius right here, we're going to go 18 squared times pi, divide by 2. At this point, you may get out your calculators and get me this. If you have a pi key, use it. Take your decimal to the second decimal place. Alrighty, folks. You should have gotten approximately 508.94 if you used a pi key. Thumbs up if you got that.
Oh, I got that.
Okay, that's slight decimal variation is fine. Okay, so right here, our base we already have is 36. So we're going to go 36. Can you physically draw in your height? Uh-oh.
I appreciate you very much.
Huh.
Giving me everything that I'm about to-
I'd like you to do this for me, please. I'd like you to shade that.
We've got to do the paragraph.
Okay, watch carefully. Can you sweep all 3 angles? If you have 3 equal sides, you have 3 equal angles. Which means the yellow triangle is a...
Right angle.
I'm waiting for the chance to start. 30, 60, 90. Short leg, root 3, short leg times... Wow, let's try this again.
My God.
Okay, all together, folks. Ready? And 30, 60, 90. Short leg, root 3, short leg times 2. Okay, which means if this is your short leg from here to here, you times by root 3. That means our height is 18 root 3. Now, to do this on a calculator, you do root 3 on your calculator. Do this now. Square root of 3, hit the equal sign. It's 1.7 something or other. times 18 times 36
Over 2.
divide by 2. You do your own math. Square root of 18, square root of 3, times 18.
Michael, can you please stop?
Michael, stop, okay? Just stop.
Divided by 2.
Denisha's trying to do words.
Get me those decimals.
Oh, wait, no.
Take it to the second decimal place. Where's your calculator?
No. I had to.
Get out of here.
One that can spell.
Yes, sir. Yeah, we're getting there. We're just not done yet. Yeah, you just forgot to divide by 2. All right, guys. You should be getting around 561.18. Okay, now remember, this is a positive composite, so we're adding. So your final total area is, and then you add those two together. Yes, sir.
Could you also do Pythagorean theorem if you have the height be x?
Absolutely.
That's what I said. Do the Pythagorean theorem.
Why'd you do 36?
There you go.
Check for units. I don't think I gave you units, so there you go, guys. That was positive. Now we're going to do a negative one on the right-hand side. Okay, this one's a little bit easier than I'm introducing a new concept called geometric probability, which you will see on the SAT. Yes, sir.
The other classes too.
Yes, but the other one didn't work. For some reason, that's why I'm redoing it. Alrighty, this one. Let's make a picture one first, guys. So we're going to be doing, to get the shaded region, we're going to be doing rectangle. This one is negative, so we're going to do rectangle minus. We were told this is a rhombus, so mark all 4 sides equal. And then we're told that the vertex is 1.5 units away going all directions. So now we write our equations out. So you do your pictures. This is length times width. This one is going to be diagonal times diagonal over 2. Recognize those? Okay. So the first one's easy. Our length is 10. Our width is 6. So that's obviously 60 units squared. Okay. Now here comes the fun part. And I want you to now some of you see this instantly. A lot of you don't. Get them in a second. Okay, ready? I want every single person right now to put one finger on either side at the red dots. So I want one finger on one red dot, one finger on another red dot. Do this now. Physics, got it? Okay. Now, I'd like you to move both fingers to the red X's. Move both fingers to the red X. How much length did you lose?
1.5.
No, you got 2 fingers.
3. So the answer is 7.
Okay, so you can see here that you're losing from here to here. From here to here, you're losing 3 units. So the length of the squiggle is going to be what?
7.
Okay. It's,
No.
yeah.
It's 7.
Uh-huh. No, it's not 3.5, guys. Watch. This from here to here is 10. You come in 3 units. So our first diagonal is 7. Okay, you guys, I'm going to land on someone in about 10 seconds. Ready? You find me the other diagonal. Okay, put your finger on the dots. Now move them into the X's. Do you see it's 6 minus 3? So it's 3. Yes. Divided by 2. Okay. So that's going to be
10.1
21 divided by 2,
is 10.1.
which is 10.5.
I meant to say 5, not 1.
I was reading your mind. Okay, now, to get our final shape, we're going to go 60 minus 10.5.
I think it'll be 49.5 approximately.
Okay? Now, box that and write the word shaded.
Yeah. Approximately.
Box that, write the word shaded. I'm going to introduce a new concept. We haven't seen this before, but it's called geometric probability, and it comes into play a lot in SAT's percent probability. Okay. Geometric probability. There's different kinds of probability. Geometric probability is probability related to, under the word geometric, I like you to write these 2 words. It's area and volume. It's probability that's related to the concepts of area and volume. And when you do geometric probability, you're doing area. In this case, we're going to deal with area of the potential, or just write the word part, over area of the whole. It's part over whole. It's a percent. Okay, so we have a question here. I'd like you, right now, okay, and I should hear a bunch of tapping. I'd like you to just randomly tap a bunch of dots here. No, with your pencils, folks. Okay, see? Right there. Okay, now what this question is asking, what is the percent probability that a point will be in the shaded region compared to the entire rectangle? So the way you do that is it's part over whole. Our part in this case is 49.5. Our whole is 60. So you can use your calculators right now. I'd like you to get that in your calculator right now. You're going to divide. You're going to divide those 2 numbers, please. Okay. If you need to, get out your cell phone.
Whenever I can.
Get on my cell phone?
Alrighty, folks. Yeah, you divide. You should be getting around, it's around 83%. Yep. If you round it to the, yeah. Well, I think there's a 5 there. Alrighty, folks. That's how you do percent probability. Let's do 2 more. I'll make this as quick as I can. Okay. It says, find the probability. The minute you see the word probability, I like you to put the word percent above it. That a point lies in the shaded region compared to the entire square. So our percent's going to go like this. It's going to be shaded over the entire square. So to get our shaded is basically square minus how many circles?
4 circles.
4 circles. That's going to get us our shaded region. Let's write our equations. This, of course, is side squared. This is 4 times pi r squared. This side squared is easy. What is it?
36.
So there's no math there. Minus. Can everyone physically trace the 6 right on the edge?
That's a diameter, dude.
We're getting there. Can you physically trace the 6 going this way?
That's like in general.
Now let's shift it. Let's go one more. Oh, right there. Can you trace that?
You can. What about your superior? Oh, so it'd be 3.
Okay, so our diameters are what?
3.
3. But we don't need a diameter. We need a radius.
1.5 is the radius.
That's correct. So for this one, it's 4 times 1.5 squared times pi.
You just messed up my whole calculation, and now you're gonna have to pay.
Go ahead and get out your calculators. Start by squaring 1.5 times 4 times pi.
Oh God.
Alrighty, guys, you should have gotten 28 point something. What do you got? 28.27? That sounds about right. Now, subtract that to get your shaded region. Okay, always label your stuff. If you just found shaded, let's go ahead and write the word shaded. Now, percent probability in this case is the shaded divided by the whole square. So our shaded divided by your square. And then you get that decimal. What you got? Yeah, stop. You're getting about 21%, guys. Yes? Check your math. Yeah. You're fine. You're not off. It's just, we just rounded.
Oh, because I got 7.7.
You do to get
Jimmy, that's why you show your work. Alrighty, guys. Last one. Last one. Okay. Shaded region. Again, let's make our picture equation kind of, I'm just going to give you a little push in the right direction. Okay. To get our shaded region, okay, is a circle, pi r squared. And to get our shaded region, we're going to be minusing this square. Now, warning, there's a shortcut here. You might be interested. Now, get out your reference booklets. I actually want everyone to physically look at this page in your reference booklet. Find that page in your reference booklet. It's in your reference booklet. It's the beginning of this unit. Right, you just got it right there. Find this page in your reference booklet. I want you to see it. Get out your reference booklet. This page right there. It's the beginning of Unit 8. I actually want you to look at that, folks. Alrighty, folks. So you guys, for a square, you're used to the equation being side squared, right? But there's a little bit of a glitch here. There's no side. But if you look very carefully, a square also qualifies as a rhombus, which means we could do this. Watch. Diagonal, times diagonal over 2, which is a lot easier to work with. So watch out for that. That's going to come into play, guys. Okay, at this point, I'm going to pause the video and I want you to finish. Your goal is this. You want to find the shaded region, and then you're going to Find the percent probability that a random dot lands in that shaded region compared to the entire circle. Okay? All I need you to do is show me your answers when you're done, and I'll tell you if you're correct. Alrighty, guys, so take a look up here. You should be getting around 804.25 minus 512.
That sounds about right.
And we get the shaded region is, 292.25 divided by the entire area, which is 804.25. And you should be getting approximately 36. There is a 36% probability that a random point will be in the shaded region versus the whole.